Basically,
Okay, so what's your name?
my name is Ali.
And where are we?
We are at Surrey campus, SFU,
Mm-hmm.
and here is a project based on IR emitter and receiver. So basically, what these things are can basically called as name tags, which will be worn either with a clip here or as a garland. What this thing does is it will first upload your interests. So for our example, we have three interests: tabletop, CSCW, and variables.
Mm-hmm.
Now, for example, if you have tabletop and CSCW, so this mini will be programmed to have tabletop and CSCW. And for example, if this one has CSCW and variables, so this mini will be programmed with CSCW and variables. Now, when both of these communicate, the green light will blink because that is the common interest between both the name tags. So
Okay,
if
so this is like speed dating.
yeah,
but
it's probably like speed
electronic.
dating. This is the use is more in conferences. So at the moment, both of them have been configured to have all three interests. So if all three interests are in common, that means the white should blink.
Mm-hmm.
So if I turn it on and I make them connect to each other, you can see that the white light starts blinking.
Uh-huh. So how does it work?
So what it does is it bursts an IR emitter bursts signal at every 1.2 seconds,
Mm-hmm.
and for the rest of the time the receiver is receiving signals based on the received code from the emitter. The mini sends the instructions to the RGB to light up different colors, or so every interest or every combination of interest has a different code which the receiver receives.
Okay. And how did you encode the infrared signals?
So as a timeline, I first tested out the emitter and receiver separately,
Mm-hmm.
and then I joined both of them. I had a lot of trouble making both of them work together because in Arduino you can make it do one thing at a time. Um, so I first looped this guy to send 1.2 second bursts, and then for the remaining time, I told that the receiver should be on. But
Oh,
to make the
so do you mean it would emit for 1 point seconds, or that it would emit every
sorry,
one? So how long would it emit for?
how long would it emit?
Yeah.
How long would it wait for?
Well, I mean, do you mean it would be emitting for 1.2 seconds?
No,
Or?
no, it would be emitting a 10 millisecond burst after every 1.2 seconds.
Ah, okay.
Okay.
So it's listening most of the time.
So it's most of the time it's listening to the receiver, and yeah, I had some issues in the code as usual. Everyone has.
Yep.
Fixed them, and that's how it's working.
Okay. And how do you prevent a feedback issue so it doesn't receive its own
Okay,
signal?
so you can see that the receiver is actually below the emitter.
Mm-hmm.
So the emitter will be signaling this way,
Yep.
and the receiver will not be able to catch any of the emitter signals because it is actually a little lower than the emitter.
Oh, okay. Very clever.
Thank you.
And so what were some pitfalls that some stumbling blocks or and trouble points that if anybody wants to try something similar, they should be aware of?
Stumbling points. Just just be aware that the receiver does not turn on as soon as you enter the code. It needs some time to actually turn on the receiver to start listening.
Okay. How
So
long?
you need to like probably put a delay of around uh, 0.8 seconds. I
Okay.
would say
Oh, wow.
0.8 seconds should be fine.
Mm-hmm.
Yeah, and yeah, it was actually a bit tricky to configure the RGB because it had to light up for, as you can see, 7 different colors.
Mm-hmm.
So yeah, I think that's about it.
Okay. So if you have to delay for 0.8 seconds, does that mean that there's a 0.8 second chunk of every signal sequence that
Now
it's
zero
not
0.8
listening?
seconds is the wait period, so for zero 0.8 seconds it will do nothing
Okay.
because during that time it is actually waiting for, it is actually the whole system is actually waiting for the receiver to turn on.
Okay. And so is that just at the very beginning, or is it every cycle sequence?
It's every cycle sequence.
Okay.
Yeah, whenever you put the command for the receiver,
Uh-huh.
it's not actually every cycle sequence. It's actually after every burst. So
Okay.
after every 1.2 seconds,
Yep.
there'll be a delay of 0.8.
Okay. So is there a chance that while the delay is happening, that it would miss a signal input from another name tag?
So while the delay is happening, it will not, because it has already been the receive code has already been sent,
Mm-hmm.
and then the delay signal comes in. So if so, during that delay, the receiver is actually on, or it's turning on. So
Okay.
it will actually receive the code, and if it has a code, it will send it out.
Okay. Great. Awesome. Is it awesome?
Yes.
Awesome. All right. Thank you.
Okay, thank you.